This lecture is on solving exponential and logarithmic equations. We'll start with the easy stuff and work our way up. Beginning with this example, note that in every one of these 6 cases we can match up bases or log bases quite easily, so we can get simple exact answers. So 2 to the x equals 32, we can express 32 as a power of 2, so 2 to the x equals 2 to the 5th, therefore x is 5. We equate exponents. Here we can add ln 3 to the other side. Of course, x has to be 3. We can express 1/3 as 3 to the negative 1, 9 is 3 squared, and match up exponents. Here we can just take the natural log of both sides, and we get x is ln 7 because those are inverses. Same idea here, we exponentiate both sides. E to the ln x cancels, and so our answer is e to the negative 3. And here we can, again, exponentiate both sides. But we're going to get into some more challenging ones. So here we have e to the x equals 72. Well, we can't express 72 as a base e easily, but we can take the natural log of both sides simply enough. And so we end up getting x is ln 72. Over here, realizing that to solve an equation often it means sort of unwrapping it. We first divide by 3, so 2 to the x is 42. And then what we can do is take a log base 2 of both sides, so these cancel, and x is log base 2 of 14. Then we can do a change of base and have ln 14 over ln 2. Alternatively, when we get to here, 2 to the x equals 14, we can take a natural log or a common log of both sides and then bring our exponent in front. And I will show an example later with that style rather than using the change of base formula, though either way works. Here again, unwrapping the equation to get x, add 3 to both sides, divide by 4. Now we've got to deal with the fact that our variable's in the exponent, so we take a natural log of both sides. The ln and e cancel. 2x equals ln 5/4, divide by 2. Over here, similar idea, add 4, divide by 2. We have a base of 3, so we can take a log base 3. We have to add 5 and divide by 2. And finally, we get to a point where it's log base 3. So do that in your calculator if you have a newer operating system, or use a change of base formula. Now it gets a little more interesting. We have e to the 2x minus 3, e to the x plus 2 equals 0. We imagine that this can be written in a quadratic form because e to the 2x is e to the x quantity squared. And then we can factor. We have e to the x minus 2 times e to the x minus 1 equals 0. Setting each factor equal to 0, we'll have e to the x equals 2 and e to the x equals 1. So our answers are ln 2 and ln 1, and ln 1 is 0. So we have ln 2 and 0 as our 2 answers. So that's mixing the algebra in with the exponentials. And we see that also with logs a little bit later. Here we have ln 3x equals 2, so now we're focusing on logs. To unwrap the equation, we can exponentiate both sides. E and ln cancel. 3x equals e squared, divide by 3. Over here, same log on both sides, simply exponentiate both sides with the base of 3 and remove them. We get x equals 2. It's important, though, to check your answers in the original problem just to make sure you don't have extraneous solutions with logs, since they have a domain which is only positive numbers. Over here, subtract the 5. We have 2 ln x is equal to negative 1. Divide by 2, and then to get x by itself, use a base e on both sides. This cancels, x is e to the negative 1/2. Over here, again, to unwrap this, divide by 2. Use a base 5 both sides to cancel the log base 5. These cancel out. 3x equals 25, and divide by 3. Here we'll have some extraneous solutions perhaps to deal with. We would like to get rid of the natural logs, but we can't do that with multiple logs added here and there's 2 in front. So we got to do a couple things. First, we combine these 2 logs using log addition properties. We have a log of a product, and on the right side we put the 2 inside as an exponent. Now we're able to remove the logs from both sides. We foiled this as well. We can subtract x squared. We have a quadratic, and we factor it, and we get x is 6 or 1. If you put 6 or 1 in here, either way, you're not taking a log of a negative number or 0, so that should be okay. Now going over to some examples from the textbook. We have 5 times 8 to the x equals 325. I can divide both sides by 5, so 8 to the x is 65. At this point in the textbook, they would have used a log base 8 and used a change to base formula. Instead, just to show an alternative method, I'll take a natural log of both sides. So we have ln 8 to the x equals ln 65. This exponent can then go in front as a coefficient. And finally, I can divide both sides by ln 8. So I have ln 65 over ln 8, approximately 2.0075. It makes sense a little bigger than 2 as far as the logs go. This is simple enough. This is just the whole idea of e and ln canceling. So negative 8 plus x cubed, not much there. Here again, we want to get the exponent, the variable out of the exponent, and so what we'll do is take a natural log of both sides. I prefer to do that rather than change the base formula, though that way it works. I can put the 5x in front now as a coefficient. Divide both sides by 5 ln 6. So my answer is ln 3000 over 5 ln 6, approximately 0.894. Over here, this is an example again of this quadratic form of an exponential equation. One way to think about it, if it makes it easier for you, is to imagine m is e to the x, so therefore m squared is e to the x quantity squared. So we would have this quadratic m squared minus 5m plus 6 equals 0, and then we would factor it. Alternatively, if you just see it like this, it works as well. And so we factor each of these. We set each factor equal to 0. We have e to the x is 2 and e to the x equals 3. We can take a natural log of both sides, then you'll have x is ln 2 and ln 3. Finally, here we have a logarithmic equation. We can't get rid of these logs, though, until we have just a single log. So what I do is I combine them. A sum of 2 logs is the log of a product. I can exponentiate both sides with the power of 3 to cancel this. So I do it on the right side as well. So I've got x times x minus 8 is equal to 3 squared, which is 9. Distribute and subtract 9 from both sides. I've got a quadratic, and then we can factor, and I get x is equal to either 9 or negative 1. However, you can't take a log of a negative number, plugging it back in, that wouldn't be in the domain, and so the answer is simply x is equal to 9.